Dear student, today we will see how to find centroid of a T section. For that, we will consider one problem. Find the centroid of a T section having flange 200 mm by 20 mm, web 20 mm thick and overall depth 200 mm. Now this is the T section. The horizontal portion is known as flange, that is 200 by 20 mm. Web is 20 mm thick, all dimensions are in mm, and overall depth is 200 mm. Now to start with, there are, see, 4 to 5 steps to solve this problem. First of all, what we will do, we will select a reference x and reference y axis. We will select reference x and reference y axis such that the given figure will be in the first quadrant. So select reference axis such that the given figure will be in the first quadrant. Let us consider this as reference y and this is reference x. So these are the two axes. Now this is, we can call this as origin. So the given T section is in the first quadrant. Next step is to divide the figure into regular figure. So as this is a T section, I am going to divide this in this top rectangle, that is 200 by 20, and bottom web rectangle 120 by 180. I will call this flange part as 1 and web part as 2. Okay. Now in the next step, I will locate the centroid of each part. So part 1, that is flange rectangle, centroid is here as it is a rectangle. It is at a distance. The distance from reference y is, I will call this as x1. Always I am measuring distances of that centroid from reference axis. The horizontal distance between the centroid of that part 1 and reference y-axis, I will call that as x1, and the vertical distance of the centroid of part 1 from horizontal reference axis, I will call that as y1. So this is y1. Similarly, I will locate the centroid of this web rectangle and I will denote its centroid from vertical reference axis, that is ry, as x2. So this is x2, and the vertical distance between the centroid of part 2 and horizontal reference axis, that is rx, is, I will call it as y2. Now prepare a table, serial number, figure number, its x distance, that is horizontal distance of its centroid from reference y, and y distance, that is its vertical distance between the centroid of that part and horizontal reference axis, that is rx, is y. Now serial number 1, figure number 1 is figure details. It is a rectangle 200 by 20. 200 by 20 is the flange rectangle. its area, figure number and area. I will call this figure number and area. So area in this case is 4000, of course in mm square. X distance is 100 mm. How? See, x1, for one x distance is x1, that is its distance from vertical reference axis ry, that is x, and y, remember, y1 is the distance between the horizontal reference axis Rx and its centroid, its vertical distance. In this case, it is 180 plus 10, that is 190. 180 plus 10, 190. Then serial number 2, that is the wave rectangle, that is 20 by 180, that is 3600. Its x distance, that is x2, is 100, and y2, that is 180 by 2. See, height of the wave only is 180, and the distance of its centroid will be at a distance 180 by 2, that is 90. Now let us use simple formula. X bar is equal to a1 x1 plus a2 x2 upon a1 plus a2. In this case, a1 is 4000, x1 is 100, plus a2 is 3600 into 100, that is x2, divided by 4000 plus 3600. If you simplify this, you will get 100 mm. Actually, there is no need to calculate because the figure is symmetrical about vertical axis. But as it is a first problem, I am going to show how the x bar is calculated. Then y bar. For y bar, the formula is a1 y1 plus a2 y2 upon a1 plus a2. Here a1 is 4000, y1 is 190, plus into bracket 3600, that is a2 into y2 is 90, divided by 4000 plus 3600. If you calculate, you will get y bar as 142.63 mm. What does it indicate? It indicates that the centroid of the given figure is at a distance 142.63 mm from reference x-axis. So here somewhere the centroid, its a distance from reference x-axis, that is y bar. This is y bar, and y bar we got as 142.63 mm, whereas its distance from reference y-axis, that is x bar, this is our x bar. X bar is 100 mm. X bar we got as, this is x bar 100 mm. So by this way we can calculate the centroid of the given figure. Thank you.